In this video, we're going to look at a couple of problems that will help you on your Unit 1B quiz number 3. So a couple of these problems I just pulled straight from the lesson 19 practice problems, and then I also have one additional one that I just kind of created. So this first problem is lesson 19 practice problem number 1. And this one is just asking what is the measure of angle ABE. So let me get ABE drawn on here. So remember, when you're looking at an angle, you can just follow the letters. So ABE, so we're asking for this angle. And this angle is a vertical angle with the 40 since it's created by these two straight lines. And we know that vertical angles are equal to each other. So that angle measure is going to be 40 degrees. Also remember, don't forget that straight lines total 180. So if you needed to find the other angle measures here, you could do 180 minus the angle given. So 180 minus 40, and you would get 140 for this angle. And then across from that would also be 140. Okay, then number 2 has us taking a look at this diagram and reading through all of these statements. So part A says that angle C plus B, so those lowercase letters, so C plus B, okay, which we know totals a straight line. So C plus B is 180, and this says equals D plus C. And so here's D and here's C. Those make a straight line as well. So those are also 180. So we know that those two sums are the same. So this is a true statement. B says that D plus B, so D plus B equals 180. That's false. They're across from each other, so we know that D equals B. We don't know that they equal 180. All right, then this next one asks us to rotate clockwise. So I'm going to get these kind of points on here. So let me get this one is A, oops, C, D, and E. Let me get those written on here so we can see where they land. All right, so this first one asks us to, let me get this highlighted. This letter C asks us to rotate clockwise by angle ABC. So we're going to want to rotate by angle ABC using B as the center. So B is going to stay in place, and we're going to rotate by this angle, which means move this side over to here. So we're going to move this point A all the way over to this side where C is at, okay? Making sure to leave B in the middle, okay? So rotating, keeping B in the middle. So there's the rotation by that angle. And then let me just erase a little bit of this so we can kind of see. So now this says then angle CBD is the image of ABE. If they're images, they would land on each other. So is angle CBD on top of ABE from our original? ABE from our original. And the answer to that is no, it did not land on ABE. So they are not images of each other. Okay, so then we'll put this back. So D says rotate 180 degrees using B as the center. Okay, so now we're going to rotate 180 degrees. So you can kind of watch this point E go all the way over here. Or my green dot is going to go all the way to the bottom. That'll be a 180 degree rotation, and we wanted B to stay in the same spot. And so now it's saying that CBD, okay, so our new CBD, whoops, angle CBD is the image of EBA, so the original EBA. And so if we take a look at that, we see EBA is where that new angle landed. So this one is true. Now it says to reflect over the angle bisector of angle ABC. So let me get this put back. So reflect over the angle bisector. So this one's going to be harder for me to show you on the screen because I can't really fold it. But we'd be doing over the angle bisector of ABC, which is right in the middle. And then you can, if you were folding on tracing paper, then this ray here or this angle here would go directly over here when we flip over that angle bisector. So then our CBD and ABE images of each other. Okay, so if we just kind of look at highlighting where a CBD would land, which is this purple angle, is that on top of the original ABE? And it is. So this would flip over onto that one. So this would be true. And then the final one, oops, let me get that back on there. So the final one is asking us to reflect across line CE. Okay, so if we were going to reflect on this line, so you're going to fold it over. Okay, so if we fold this over, this is going to land here. Okay, and D is going to land, so perpendicular to the line, and then up is going to land here. So it would end up that you'd have these kind of two lines. And if you had tracing paper, you could do that and fold it. But then our CBD and EBA going to be reflections of each other. And you can see that this didn't land on those other angles. So this one would be false. All right, the third one I'm going to do is number 5 from lesson 19. And this one is just talking about describing a sequence of rigid motions that will take A, B, C, D to A prime, B prime, C prime, D prime. So if we were going to do that, and we're going to describe the rigid motions. So first we're going to want to translate and get an image, get the point onto its image. Okay, so we're first going to translate A, B, C, D by directed segment A prime is fine. You could do B prime, anything that will put the point on its image. Okay, so that's going to be the first thing. And so I'm going to do A prime. And so then this will move to here. Okay, now we're going to need to rotate. And so now we can rotate. And if we remember what point this was, so this was point B. So I'm just going to say rotate kind of that new shape, the ABCD, the purple one, until segment A prime or AB lands on A prime, B prime. Okay, or lines up with A prime, B prime. That's one way to say it. You could also say rotate until B coincides with B prime. So that's another way you can say that one. And then if we do that, okay, you'll see if we rotate and keep A the same, that then it lands directly on the other one. All right, then this final one is talking about when we have two parallel lines, and we can see parallel because of these arrows. So these mean parallel. Now we want to fill in all of the angles, all the missing angles. So remember that vertical angles are equal to each other. So if this one is 60, and why don't I get this same color, then this one is 60. Okay, and then we can subtract it from 180. So 180 minus 60 gives us 120 for this one. And then therefore also this one, that's a vertical angle to it. And then if we think about translating these down, okay, and if we could just pick these up and move them, what they land on would be equal to each other. Okay, so if I just slide this line down, the 120 lands here and here, and the 60s land here and here. So if you can think of just picking that up and moving it down.